Hi friends, welcome to Civil Architecture Tutorials. Today the subject is regarding the centric footing and eccentric footing. So we are familiar with a situation where our land is abutting a neighbor's land, and when they have already been built their building there, and when we are going to build our home, the setbacks will be a problem. Usually, in all the countries, there is a set of standard of how to make the building in that land area, but in in many cases, most of the people are not following it, and they are making in such a way that they will make the building without any setbacks too, sometimes, or even if they are giving the setbacks, they are not concerned about giving the adequate setback, maybe 20 or 30 1 feet. They are giving as a setbacks. I have seen it. Maybe their chaja or the sunshade or balconies may come protruding out, which may extend beyond their boundary. That also can happen. So all these things are happening when people are not concerned about others necessities, the neighboring buildings necessity, or neighboring people. They are not concerned much in many cases if the rules are not following. So in many areas, such buildings have been demolished afterwards, so they have to face such things also. But in some other areas where the land is not adequate, but we need to build a particular square feet of building, and we cannot go down from that square feet. So in order to accommodate such things, the architect may have to go for some compromises without uh, deviating from the law. So at that time, we have to give the columns very near to the boundary wall, or maybe abutting the boundary wall itself. So in that cases, as we know, when the column is there, column may have a footing. It is almost like this eccentric footing. Column will be this the elevation part. The column will be like coming like this, and it will be at the center of this footing. Okay, this is the elevation, this is the plan, this is the column, this is the footing, and the reinforcement of such a centric footing is like this: the center column and the reinforcement bar will go like this in all directions, four in this direction and others in like this direction, and it will be resting on a mat reinforcement. So this is the usual thing, but this we cannot give when in this case, the case that I just said before, where the column have to abut a boundary wall, which is the boundary wall of the neighbor too. So in that case, anyway, the column we have to give. Without column, the building load cannot be distributed to the ground. So in order to give such a place where the column have to be there, but it will not be centric. In order to balance the centric forces, or the balance the forces that is coming into the column, we can go for eccentric columns. Such columns are called eccentric columns. Okay, so just take an example. This is a neighbor's plot, this is our plot. So these are the column footings. Column footings, here you can see this abutting the boundary wall of this neighbor. So in such cases, the column cannot be at the center because there is no land area available there. In such cases, we will go for eccentric footing. Eccentric footing, we can see the elevation. The column is not at the center, it is towards the side. The plan is like this. You can see this. This is the column, and from there, that distribution bar is going like this. This is the reinforcement area where the column is there, and there are two types of eccentric columns. Depends upon the placement of this eccentric columns. One is uniaxial eccentric column, other is biaxial eccentric column. So this is the uniaxial eccentric column, where it is almost at the center of that foundation, but towards the side. Okay, it's not at the center. It is not at the center, but it is at the center of this abutting area. This area, it is at the center still. So the reinforcement will be like this. It will go like this in all this area. Here it is a highlight of that reinforcement. This is the column, and this will go like this, like this. It can go in other way also. This way also it can go. From the column, the reinforcement can go like this and like this. There is no reinforcement this side. That also can be possible in this uniaxial eccentric footing. So This is usually we are doing for almost eccentric columns, but there are some occasions where it arises that we cannot give the column at center, even it is not at the center of this line on the left side. Also, we cannot give at the center. It is when the beams on the corresponding on the sides of the other columns is coming to this column, and we have to balance it, and the area or the length of that beam to beam length also have to be maintained. In such cases, we have to go for biaxial eccentric footing, where the column will be to a corner of that foundation pit. Okay, so this is the footing, and it will be at a column. Sorry, it will be at a corner. So such a column is called biaxial eccentric footing. Here we can see the reinforcement of such a thing. The all reinforcement will be in only in one direction, like this. The column will be there, and all the reinforcement will be like an L-shaped. It can be placed at any corner. Any corner, it doesn't matter. So that is the bar bending schedule of that particular column. This is biaxial, which will be at a corner, and this is to balance the beam length of other columns or the design, and also in such peculiar situations in which that particular column is abutting a boundary wall. So again, I am telling, centric column are the usual columns that we are here seeing everywhere. But when it is the areas abutting, and when we don't have much area for to place centric column there, we go for eccentric columns. And eccentric columns are two types. One is uniaxial. Uniaxial is also comes to a center, but on the one side. This is uniaxial, and this is the reinforcement drawing. And this can be in this way or this way. We can give reinforcement. And the second one is biaxial, where the uniaxial is also not possible. The column have to go to a corner in order to keep the length of the beams and also to balance the forces. So this is a general discussion regarding centric column and eccentric columns. Hope you understand it. I will come with a new video with a new subject. Till then, goodbye. Please subscribe, share, and like my channel. Thank you very much.